All right, let's get this going. Let's get it going. Good morning, you landlubbers. We are outside today doing this stream from Mother Nature in the one of the most beautiful camping spots I've probably ever found, and I'm pretty excited to be out here today. It might be a little bit hot, so we'll see how long I can do this for before I go jump in that water back there. Hopefully this stream is not lagging too much. If you guys are getting a lot of lag, please let me know in the comments, and we'll see what I can do about that, because I am streaming from you to you live outside, probably an hour from in every single direction from civilization. So this is coming to you over Starlink, and we are pretty good to go on power. I think let's just do a quick check real quick before we get this going. All right. So as you can see, we are at about 80% of our total power. We got about 64% of our main battery. We used a little bit of our reserves last night, and we are currently charging at 73 amps at 12 volt, and we're charging up at 7.6 amps at 48 volt. So we should be good to go with this. Let's keep going here. So for the last few days, we have been working on a license app server, and I got a little sidetracked, not gonna lie. We'll probably pick that back up and come back to it in a little bit, but there's so many cool things that have been happening. So Laguna S 2.1 came out, and XS, and if you're not familiar, you should go check those out. But they're really strong models that can run locally on your machine. And so I have been optimizing that. If you go and you look at a project, pull this up here. It is called MLX Fast. So this project is basically anyone with some extra compute can go and throw their agent at it, and this thing started out at 79.8 tokens per second running on a local machine. That's an M5 Mac actually. And then over time, as you can see, these various models have been just making ever so slight adjustments to the code that does the predictions and the inferencing for this model. And the cool thing is, this project actually is a byte exact output match. So none of the submissions by the agents that are doing the improving of these models are actually even considered if they don't have a 100% output match. So we basically, when you can take an AI agent and you can say, here is the expected output, now go optimize for this. You can have it go and do a lot of different things and try a lot of different things. Maybe you're using like an auto research extension, but basically what you want to do is, you know, just point your agent at it. It downloads this code. Like if you get the participate, I just leaked my key to everybody, so I don't even know how I'm gonna rotate that, but there it is. So anyway, basically you will do these submissions. You can see I had a whole bunch that I was trying with GLM. They were all failing, and that's because I'm running these on an M3 Ultra, and so a lot of the optimizations it was making work on the M3 Ultra because it has very unique characteristics in terms of like memory bandwidth that the M5 that it's being tested on doesn't have. So some of these were rejected, but as you can see, some of them were improved and they actually improved the token output. So that's pretty cool. That's basically what I have been working on lately. And oh, that's not what we wanted. Let's pull this. And then you guys can get what we're going to do next here. Just give me one moment. Just copy these instructions here real quick. I need to fix something because I just leaked my QD guys, and that's not good. So just fix this real quick. Okay, now that we rotated that appropriately, so anyway, if you have some extra compute and you want to go and use your compute for something good, go check that project out and you'll be helping to speed up your inferencing and everyone else is inferencing when they're running Laguna XS 2.1. I think the theory is that a lot of this should translate over directly to Laguna S 2.1. So basically what I've been doing now is I've been taking those optimizations and running them through auto research. So let's pull that up so you guys can see here. Oh, should probably put a capture device in. Well, if you guys can't see this, let me know if it's too small. But that's what we're gonna do. We're gonna go with this right now. Actually, let's do this. See, what am I doing? What am I doing? It's a terrible idea. Absolute terrible idea. Let's fix this, shall we? Here's what we're gonna do. We're gonna take that, blow it up so that you guys can actually see what's going on. And then we're gonna take this guy. I'm just gonna bring him on down. Bring him on down. There we go. That's a lot better. Okay, so basically, this has been running now for 1 day, 17 hours, and 28 minutes. And the general idea, and you can see we're getting like a lot of just crashes now. Discard. Hey, we got a keep in there. That's pretty cool. So this again is running on the M3 Ultra. It is not running on an M5. The M5 has specific hardware things that make it a little bit faster to do AI inferencing, especially pre-fill nowadays. So if you have an M5, you might want to wait to see if they like come out with a Laguna S2.1 challenge. Because right now they're doing the XS challenge. And if they don't, you can just throw it at auto research. So this is Pi that I'm running, and I have an auto research extension for Pi. If you go like look on the standard Pi dev website, you will see all of the different Pi extensions or packages, and this is just another one of those packages. And so it's done 264 different tries so far, but basically it goes through, it modifies the code. I have it set up to look for byte exactness, so it's not allowed to make any changes that don't produce the exact same output from the model. One quick thing I want to get back to real quick that I think is really, really cool with this. Let me just pull this back up so you guys can see this, because I just want to point this out. I think this is so cool. So we're like 100% faster than we were when this first started. 145.2 tokens per second for a local model that is going head to head with like Qwen 3.6 35B A3B. I mean, that is really impressive. And on my local runs, I'm getting a, let's see, what is it? Does it tell us on here what we're at? No, unfortunately. I can tell it, I'll prompt it to do that so that it will have to figure out where we're at. But let's see. Can you let me know what tokens per second we are at with all of our optimizations, including DFlash? Maybe let us know what it is with DFlash and without DFlash. So right now, there's two really cool things that I wanted to show you about this. One, this model is being optimized without DFlash. So this is 145.2 tokens per second with no speculative decoding. So if they turn on speculative decoding for this, it might go even faster. It's a pretty small model. It might not need speculative decoding at all. In fact, turning it on could even make it a little slower. But this is pretty sweet. The other thing I think is really cool is the last two people. So I know Ivan's got two of these M3 Ultras, so maybe he's running Kimi locally at home. I don't know. But the fact that Kimi is, it's probably Kimi K3, is the model that has pushed the two latest boundaries, I think is just really awesome. Looks like Ivan was running GPT 5.6 Sol down here. So maybe he's using a Kimi plan, I don't know. Gumby Digital also has an M3 Ultra, I'm fairly certain. So, you know, these are probably people we've also seen around the Dark Bloom project. You know, this is the project that is allowing anyone to hook up their M series Mac machines and start serving inference requests and get paid for them via either like directly through here in USDC where you just connect your Stripe account, and people pay through this website to get access to inferencing, or this is actually hooked up now directly to OpenRouter. So these like 900 requests that you're seeing coming in right now, these are coming in, this is coming in from OpenRouter for the most part, and this is being served from OpenRouter, which means you can hook up your personal machine now and get paid from OpenRouter requests. Some of these people are on track to do $5,000 a year in earnings, which is just awesome for having a machine plugged in that you're not using at night or something. You know, the whole idea of this is like, this is idle compute. So this is your machine is not being used at night, or, you know, maybe you're not using it at certain points of the day. Even if you are using it, chances are, unless you're using it for inferencing, your GPU is sitting idle like 98% of the time. Unless you're running like Blender or apparently the new OpenAI Codex app uses like 70% of your GPU for absolutely no reason. I can't figure, maybe they do a crazy spinner animation, who knows. But otherwise, these people are just getting paid for running this stuff locally. I mean, that's $5,000 for running for the year, I bet covers the utility costs. Now, I love this project because, as you can see, I'm out here, I'm outside in the middle of nowhere. We've gone over this, but I run everything off of solar power. So I don't have to pay for solar. I've already bought the solar panels. I live off the solar anyway, and I just had surplus power. So, you know, instead of running out of power if I don't put my panels out in 10 days, maybe I run out in 3 or 4 days, 5 days. But, you know, all I gotta do is put them out for 1 day and I have enough power again for 5 more days. So that's pretty awesome. So here's where we're at. And I'm not really sure what I want to do yet today, but I would like to know where we are at with speeding up our thing here. So did it process my prompt? It looks like maybe it did. So without dflash, it's saying that we are doing 54.43 decode tokens per second. With depth, 15 dflash. That's pretty deep. Usually when I run like MTP for like Qwen 3.6 27B or something, I'm doing like depth 1, maybe depth 3. But with depth 15, it's getting 50.87 tokens per second. So it actually goes down, which is shocking. So obviously we would not want to run this with dflash. I do wonder though that, so I have, the way this is benchmarking is it's doing some pretty small prompts, like 128 tokens, 256 tokens, and then I think I have one in there that's like the max 200,000 roughly tokens, so that I can get a good, you know, broad spectrum of token sizes. So yeah, I think we're at the point where we've optimized this really, really well. It's still going. It's gonna keep going. But right now it's been using my GPT Max plan, as you can see. Oh, you can't see because it's over here. But yeah, I'm running GPT 5.6 Sol Max to optimize this. And because it spends so much time doing the benchmarking, it's actually not burning through the GPT 5.6 Sol plan very quickly, which is kind of awesome. Let me see if I can get that up here. So everything else in the world wants to show up. Let's see. Can I hide? I need all that. This, hold on. So I really am getting bugged by the taskbar. Like everyone creates a new taskbar app, and there's no way to like, unless I use like the bartender app, which I've tried, it does not work, even the new one. And so I need a way that like the top bar of my screen is like scrollable or something of my tabs. And I think they may have done something in the new iOS 27 beta where now the thing goes on the other side, but we'll see. We will see. There's gotta be a way to fix this. Yeah, let's remove that. Okay. So I'm looking at it currently at 46%. This thing has been running for 1 day and 17 hours, and it's used about 54% of our codex plan. So that's really not too bad for getting these kind of optimizations. But here's the thing that I really want to do. Now that we have this working in a good spot, I'm going to use this model to optimize itself. So to do that, we're going to need to figure out a really, I mean, I would like it to automatically pick up the updates, but I think right now I'm probably good with it just like starting the server and then going from there. So let's get this thing to boot up a server for us. It's already pulling up the auto research, which is fine, but I'm not really wanting to do that. So what we're gonna do is we're gonna switch over to our trusty GLM 5.2 model, and I'm going to tell it, in this project we have the Laguna S 2.1 model, not the Laguna XS 2.0 model. I want to get that served up via the server so that I can start using it in Pi. We have another agent that is still running in this directory, so do not clobber their work. They're doing auto research on improving the speed of running this model. But while it's doing that, I still want to just get it running so that I can start using it. And just to clarify, I'm going to tell it that I do not want the Laguna XS 2.1 because that is a... Boom. Let's see if it can get this up and moving for us. We can try it out. So the thing about this model is that it's supposed to be really good. I haven't actually used it too much for coding. It does have thinking mode, but it doesn't really use it apparently very often. So everyone's saying to just turn it off and use like the Flash version. I guess it's not the Flash version, it's just the non-thinking mode. Oh, by the way, I switched from Tmux to Herder, which is pretty awesome. I gotta say, I'm really enjoying it. You can basically set up all your same Tmux bindings, except there's like this enhancement where it's more integrated now with AI agents. So you see I have my Tmux workspaces over here, and each workspace then has multiple tabs. And then down here, if any of these tabs are an agent, whether it's Pi, Codex, whatever, there's like plugins you can add, it integrates it down here. So I actually get like a little chime when this finishes so that I know to come back to it. The other really nice thing is I can set up my key bindings like this so that now I can easily switch between these. So this is that game we've been running. Been having GLM 5.2 run for a really long time. Looks like the compaction is still broken. No matter how many times I try and fix it, doesn't want to work. So we're going to get that to continue, but you can see that this Wave RTS is actually in a completely different workspace, right? Like it switches not only the workspace, but it allows you to easily iterate through each of your agents really quickly. And you can even set a key binding to have to go to the agent that's done. So like you can see this one's complete over here. I could easily have like a key binding that goes to it. There's also these nice little windows like this one that show you these things. And then there's these different states down here, right? So if like an agent's idle or done or whatever, like you can easily switch to the agents with those states or filter them out. So are any of our agents blocked? No. What agents are working? Okay, it shows us those. It shows us which agents are idle. And then A is just all. So that's kind of cool. So we're gonna let that run. Over here we still got cool. So it's saying that our model is fully serving now. Make sure that port you chose is the correct one set for this model. Still gotta say, GLM 5.2 might still be my all-time favorite model. It just gets shit done, which is so nice when you have a million things going. So you can see it made an optimization here, and we're at 0.93. This needs to get to 1. If it doesn't get to 1, then DFlash is not any faster than just running the model with the optimizations that we've already made. I don't really believe this thing sometimes because I saw it modify the wrong thing in the past, so we're just gonna go, we're gonna look for ourselves. 80/30. Perfect. I don't know what's up with that URL though. So let's see. Okay, so let's see if this model works out well, shall we? Yeah, let's do it here. Let's go to our project directory. Which should be here. Can you tell me what the weather today is in Whitefish, Montana? Let's see what it says. So the first one of these prompts is probably going to be a little slow because I think my initial prompt is like 20,000 tokens. I need to get that down, but with all the skill descriptions and the tool descriptions, you can really get that up quite quickly, and the caching is going to help with that a lot. But so basically what happens now is we have a hot cache and we have an on-disk cache for the server that we built, and the token cache is this key value cache is really going to help with not having to recompute everything. So every agent turn, so like you send a request to the agent, it has to like process everything, and then in your next chat message you're like adding on to that chat, and so you could have it start all the way from the first message beginning and have to process all the way through, or it can like cache that first bit and then continue on for the next message and only have to do the continuing on computation. So if I can get like my initial prompt, right? So just the stuff that gets sent with every request, that anytime I start up a new Pi session, if I can get that cached, then all future prompts should be almost instant, because it's just all it has left to process is this, right? I don't know if I've told it to do that yet, so. Yeah, Mr. Ward, I'm talking about the Carpathy Auto Research. Definitely. That's what this is. It's around 55 to 64, depending on elevation. That's definitely not right. It's more like 80 to 90. But anyway, hey, that works. The tool calling works. It did some thinking. I think this model is good to go. Let's switch out our auto research to automatically now start using this own model. So now we have a model that is going to continually self-improve itself. That's going to be freaking sweet. Yeah, let's do it. Let's do it. Okay, so we got a bunch of stuff going on here. This thing is the one that is running our server, so I don't want to stop it. I think it's actually running it as a process. So we'll just leave that running, and then we know that the model works now, which is pretty cool. So we'll just stop this one. That's all set up. Good. And over here we have currently GPT 5.6 Soul. Now let me pull this up, and you guys will actually be able to see which model I'm running when I run the models. Might be better off if they just be up here. Okay, so as you can see down here, we have GPT 5.6 Soul here, and this is now going to be the except I need to reload my Python. I don't want to cut off this experiment. So I'm going to wait a minute. As soon as this experiment is done running, then I will switch this model. Now it can forever, because I've already got the machine, it can forever try and optimize itself. Guys, that is so cool. So cool. Unless you're like one of these people that really hates AI and does not like the idea of AI becoming sentient and being able to improve itself, then I can kind of understand. But otherwise, this is so cool. Okay, we're gonna stop so it doesn't run that experiment. We're gonna shut this off. We're gonna restart this session now. We are going to change the model over to Laguna S2.1. It is now using S2.1. Thinking level really doesn't matter because if it's on, it's on. If it's not, it's not. And then we are going to say, let's just back up. Let's just leave it. I think we'll just let it go. We'll let it run and see. Continue. I had to restart. Okay, so now I should be seeing my GPU spiking over here because it needs to process this. This clearly is not right. I haven't seen the GPU spike up yet, so I just have to wait here. Make sure it's going to process. There's already a massive context in here, so it could take a little bit to do the prefill and decoding. So after we get this working, the new DeepSeek version 4 Flash version came out today. And it's supposed to be better than the DeepSeek version 4 Flash Pro, no, DeepSeek version 4 Pro preview. So up until this point, all we've had is DeepSeek version 4 Flash and Pro, but they've been the preview versions. Now they are actually releasing a new model today that is going to be, or they already did, and it's supposed to be better than the Pro. Guys, I'm gonna have to pause this real quick. Someone's coming into the campsite, so I just gotta go chat with them. And then I'll be back in a minute. Alrighty. Sorry about that, y'all. I might have to jump up again. We'll see what happens. Oh, you know what? I'm gonna have to write a program so that the music doesn't pause every time I take my headphones off. That seems like something that should not be happening. Okay. Where was I? So this thing's still processing. Okay, the good news is that it is the GPU's at 100%, so it is actually processing. I don't know what we set the context limit to though. So let's go back and check our other Pi session that we had going before and find out, shall we? It looks like we're setting it to 262. So we are at need to get my models out. I want to know what this port is because we're not actually using it. So this Laguna S 2.1 is currently set to 262,000. I want to make sure that's actually right. Like I could have swore I thought this was a 1 million model, but maybe it's not. You search the web and find out if while it's doing that, I'm gonna just go take a look at the actual Hugging Face page for that model. See if it beats me to it. Probably will because I need to get this open. Laguna S 2.1 Hugging Face by poolside. Let's see, we want the quantized version of this model that we're actually running though. Which is this one, NVFP4 MLX. Okay, so it does not tell us. Let's see. Yeah, it's a 1 million context window. So why did it set it so small? I'm half right. Okay, so it does support 1 million for long context extension, but Poolside apparently recommends 256 for output quality. I want to see where they found that. 256? I'm not seeing this. All right, Mr. Chipmunk, you can't come hang out with me, man. You come in this little tent, you're gonna get freaked out when you can't get out. There's the cutest little chipmunks out here. They're a little bit like crazy though. Make a lot of noise. Okay, so I'm looking at the base F16 card. Recommendation. Oh, so it's looking at the one I want. That's interesting. So the context window for this one, because we're now in the F16 format. Oh, interesting, interesting. But we're on the MLX version. So let me pull that one up. Because the one that we're actually running is this one. Either way, I don't think we want to make the context 1 million because that's just going to blow it up. And yeah, it's going to make the results not as good. So I think I'll probably just leave it lower, but it would be interesting to know. Also, let's see. It says I'm using 508 gigs of RAM, but I'm fairly certain that's because of the hot cache. Okay, since this is the checkpointing we're at, let's just leave it at 256K. I think we do need to look at how much RAM we're using for our hot cache because we are currently using 508 gigs of RAM on this machine, and that's a little bit too close to its 512 gig max. So maybe we need to, make the hot cache use 30 or 40 or 50 gigs less. Okay, and then the other thing that I really want to do before we even get going with any of this is I want to make sure that our little server here that we put together for this model can reuse our initial session context out of the. So I'm gonna have it do that. Because I want to be able to start up a new session and it, like, immediately to be able to answer my question because it already has the previous stuff cached. I thought it was really interesting that OpenAI published a new benchmark for their Luna model, which is supposed to be the second tier up from Terra. This is Terra Luna Sol, and it's like not as good as GLM 5.2. I mean, it's like kind of on the same level at its highest thinking. Just wild. Let's see if I can. People have been posting like crazy all day, so let's see. Okay, this isn't exactly the one that was created, but it does highlight something that I also want to go over, so I'm just gonna pull this up real quick. This is wild. Okay, so here's like the new benchmarks, right, for Luna. So Luna Max is basically on par with GLM 5.2. The only reason it's further to the left over here is because they're saying in API costs it's less, but you can run GLM 5.2 at home. You can't run Luna at home. So I'm going to mark GLM 5.2 in the free category and move it all the way over here. The other thing that's pretty crazy is now the new DeepSeek version 4 is coming out. So they already released Flash and Pro. So this is the new, is this the new one? Yeah. So this is where the new DeepSeek version 4 Flash sits that came out today. And it's almost up there, according to this. It might even be higher on other tests, as far as I know. So that's pretty wild. That's what we're going to do next. I'm going to get this pool side up and running. We're going to have it keep optimizing itself. And then we will, while it's doing that, I'm going to start up checking out the new DeepSeek version 4 Flash. Just depending on where things are at, and maybe help optimize that one, switch over to optimizing that if we do get a lot better results. So what's our thing saying? Anyway, some people are saying that the new DeepSeek version 4 Flash might dethrone GLM 5.2. And if that's the case, and we can run it locally, I'm going to be very happy. I mean, GLM 5.2 just has this like magical ability to go and do research stuff, so I don't really know if that's going to happen, but we're going to see. I do want to go check out to see if does not look like. Yeah, we're just gonna have to wait to see what happens with DS4, see if he gets it in there. It's supposed to be the same architecture, I think, so it should be like literally just using the new model to run it. So we'll see what happens. Okay. I feel like it's running the server. It's loading it up. Seems to still be loading. Okay, I'm gonna let that go. Let it keep loading. This obviously got killed because we are restarting the server, so the memory's still climbing, so the model must still be loading. You know what? I'm gonna switch this over. One thing that we also want to check on is so here's basically what I need to be able to do. I want to be able to start up different Pi sessions, and there's like some initial stuff that gets sent as part of my Pi session, like the initial prompt. And I think the initial prompt is probably something like 20,000 tokens, but I'm not entirely sure. And each time we start up the initial session, I don't want to have to reprocess that entire initial prompt that Pi sends for every new session. Like, it would be really nice that if after the very first one, then we cache those tokens and then we can reuse those tokens, that token cache, the way like I would expect it to work, such that every time I start up a new Pi session, I'm not having to reprocess that initial prompt every time. That is part of Pi. Obviously, my prompt that I send, should be like at the end of it or whatever, and that prompt. So, like if I say, what is the weather today? All of the stuff like my tools and skills and anything else like the system prompt that gets sent beforehand, I want that to be processed if possible and stored in the cache and reused across sessions. Is that something that we can do? I want you to look into the code and figure out some more if that's something that's even possible for us to do with Pi. And our server that we've implemented here. So I'm pretty sure I'm pretty sure OMLX does this. So what I'm going to also do is I'm going to tell it that. So in here, basically what I've done is I've pointed it at a bunch of these different projects. So we have OMLX right here. And now I can just grab that source. Let's just do a reset on this so we have the latest version of it. And then I'm going to tell it, I think OMLX does this. If you need to, it's the source. So this thing completely opened back up to 508 gigs again. I'm going to do this. I just stopped your last also we are all right. I think I might go stop the auto research. So let's just go pause this and then we're just gonna stop it. Nope, I said stop it. I think my goal extension or something is just way overzealous. So even though I did pause, it still ran it. I don't like that. We're gonna have to fix that at some point. Okay, so GLM or GPT 5.6 Sol is now saying yes, this is exactly what prefix key value cache is meant to do. I'll investigate read only because the repository still contains the other agent's uncommitted work. Oh, so it's saying that the immediate 508 gigabyte spike is not hashed key value state. The transient memory required to pre-fill the enormous uncached prompt. Okay, so it's saying that OMLX has block-aware cache that appears designed to solve precisely the caching reusable prefix blocks. Current server logs only a current cache miss. The subsequent stored line. Okay, so I'm going to let it know. I have stopped the other agent that was doing the auto research for now until we get this working in a way that we want it and so that we can make changes. I like this temp because it keeps all of the flies and bees and stuff away from me, but there's no airflow through here. The screen mesh is like designed for like the most ultra fine gnats ever to exist on the planet, and so air doesn't really go through it very well. I know this is quite the side quest, but if we can get this working and super fast, how sick would that be? Having this awesome model being able to do this. I don't know if we might find out the DeepSeek version 4 Flash, the new one that came out today, is actually even better. And if it is, then maybe we'll have to go use that. But this is pretty cool if we can get this going. So it looks like with the server shut down, we're using about 33 gigs of RAM. Just because I'm running a whole lot of other stuff. I think I have like Blender open and whatnot. Because the other agent is actually developing a game. It's running the game, opening it, playing it, and then also developing assets using the Blender MCP. Let's check on it. Looks like it's just adding a lot of key bindings now. It's been doing that for a very long time. I probably have enough RAM to run the FP16 version that could maybe handle the 1 million context length, but honestly, I feel like it might be a little too slow. Ooh. So I think the way that this auto research is set up this project is it applies patches to the existing code, because what I'm doing is every time on MLX Fast a new frontier is published, it goes, it grabs the new frontier, and then it runs it. So I don't want to be on like an old version if there's already a faster one, you know? May as well run the faster one. I do think a 262,000 token context is just a little too small. It's like GPT 5.6 Sol will burn the whole context and then some doing research, and it kind of like forgets the research some of it that did, and I've seen it have to do it again. So there's that. Yeah, here, tiny little camping chair I'm sitting in. When you live in a van, you got to have small stuff like small camping chairs. Whew, when that breeze comes through, oh man, that feels so nice. It's getting hot in here. For any of you guys out there watching, am I lagging? Let me know if I start lagging. I might have to figure out what to do about that. because I'm going over the Wi-Fi directly to the Starlink Mini. So it's the Starlink Mini router, which is usually pretty good. The angle at which I am sitting right now is maybe not great. The Mini is probably 10 feet above me, but like there's a whole ass van between me and the Mini, so I'm sure it's blocking it. So I gotta give them mad props, because I've like done a lot of work with antennas on this van to get the Wi-Fi to project down here because of the way the radiation spread works with a lot of these antennas. And so the fact that the Mini is completely surrounded by solar panels, so like there's solar and then the Mini sits down inside it. And so it's blocked by all that. It's blocked by a whole metal van, right? And then I'm sitting like down over here, right next to the van, on the side of it. And I'm still getting full like bars on the Wi-Fi signal, so who knows? Usually when I'm streaming, I like to be plugged directly into the Ethernet, so that I don't have to worry about any lag from Wi-Fi stuff, but we're outside today. What is this thing doing? I think it's working on the cache, hopefully. I want you to create a goal to work on this and make sure the goal includes validating that it works by starting up Pi a few times and benchmarking to make sure that the cache is actually being used and the response is faster. So I'm about to run out of context, as you guys can see, and when this happens, and we've been going for a while, I've already compacted a few times, just having it create a goal really helps, because sometimes it forgets like what it needs to check. So it's gonna compact here pretty soon, and then it's gonna keep running, and then it will eventually like do the verification all on its own now, because if it ends running its turns and then it hasn't marked the goal complete, the goal literally like sends a little thing in line and just says like, this is your goal, what you're supposed to be doing. And so then it's gonna go, oh yeah, I do need to check that, or I gotta mark the goal complete, like one of those. I do have a feeling that since ES4 is like raw C, like metal kernels and stuff, we could probably have got this running even faster inside of there. But the MLX Fast Challenge was using MLX, and you know, people have pointed like Fable and stuff at it, and if people have already spent all this money making that one model 100% faster, I had a feeling that we could take some of those optimizations and still apply them to Laguna S 2.1, you know, take the XS and apply them to S. I think it's like extra small. And surprisingly though, a lot of the optimizations that have been applied to the XS, when it went through the auto research phases, did not make the model any faster. Now that could be because that MLX Fast Challenge is targeting the M5 machine, and there are certain like I forget what it is because I don't have an M5, but it's like a local neural core processor engine, and I don't know what it is. But there's an ANI or something really like on the core itself, and so at least I think that's how it works. I don't have one, so I haven't really looked into it at all. But there are things that will make it faster on the M5 that you can optimize for. I do not have an M5. All I have is an M3 Ultra and an M4 and an M1. So the only way I could possibly benchmark that was to get an M5, which I don't have. So all the optimizations that it's making to run on this are designed for the M3 Ultra. They're verified and benchmarked against the M3 Ultra. So a lot of them that were made on the MLX Fast Challenge did not actually port over directly to make this faster for me. That's where I was going with that. One thing is quite clear though, that on the M3 Ultra, D-Flash is actually slowing things down. Now, I do wonder though, I wonder if we ran the full FP16, if it would make things faster. Because if we could get full FP16 precision, but use D-Flash to make it as fast as the NVFP4 that we're running now, that would be killer. I may have to point auto research at that and see if we can get it to do that. But I might wait, because it might turn out that DeepSeek version 4 of Flash that came out today, the new version, is just better than this model. And if that's the case, some of the benchmarks are leading that way. If that's the vibe from it, then I might have been wasting a whole bunch of time on this one. Check in with our game. It is still doing stuff. Oh, you know what? Our other thing is supposed to be running. This keeps crashing. Why did this crash again? Something wrong with our... the second time this happened, so I'm actually going to put that in here and let it figure it out. I want you to get to the root cause of what this crash, why it's happening, and I want you to write tests so that you can reproduce the crash. And after you're able to reproduce the crash, then I want you to figure out how to fix it. And once you've implemented the fix for it, make sure that we have regression tests. I mean, you should already have tests because you have tests that like show that it crashes. So you should be able to rerun them and show that it's no longer crashing. And then I want you to commit the changes and push them up. Then you'll run PyUpdate and PyUpdate extensions to install these new updates that you just pushed up. Okay, so now what we're going to do is we're actually going to go right up back here, and we are going to say, I need you to do this as a goal. And I'm going to run this on GPT 5.6 Soul Max, and we're going to see what happens, if it's able to do this or not. So let's let that run. Hopefully that'll fix some stuff. This I'm going to get re-going again. Don't know why it keeps crashing. Crashed 3 hours ago. Okay. So we'll just restart it. We'll see what happens. Now we got a lot of stuff running on this machine. Okay, so oh gosh. I have auto research on, and I think it just wiped out my auto research. It's using auto research. I forgot to turn it off. It's using auto research basically to implement these changes now. So can you tell me if you properly implemented the caching and verified that it worked by starting up Pi a few times and making sure that the cache actually worked across different sessions? We do not need to be using auto research for this. Not yet fully verified, implemented. I think maybe you should explicitly say in the goal that we should not use auto research to implement this and verify it. There. After these agents come back, you're no longer authorized to use any sub-agents. Thought I fixed this, but like, it really, really loves using sub-agents. Like if you give it sub-agents, GPT 5.6 Soul will just spawn as many as it can. The thing that I'm not sure about is what the Explorer model. So it's using Geom 5.2. That's the problem. That's going to be a problem because it's not going to explore it as well. I also do not want you to assume that the cause is what your Explorer agents come back with. You must verify for yourself because those models are not as smart as you are. So, let's see. That's why I no longer want you to use sub-agents after this. I want you to verify all results for yourself. Do all the work yourself from here on out. Okay. Boy, it's getting hot out here. I feel like I'm tropical island. It's so hot in this tent. I would totally stream outside of it, but then I would be in the sun and all the bugs would constantly be like smacking me in the face, you know? Because I can see them. They're like trying to penetrate the Fortress of Solitude here. Guys, if you haven't already, go like this video. That's gonna help me out. I don't know what it does to the algorithm, but if you like the video, it doesn't cost you anything to do a like. Just smash that like button. And then if you really want to, go subscribe to these videos on YouTube at Zayden Ryan. Same names you're watching right now on X, on YouTube, and on Twitch. But on YouTube, there's a nice playlist. You could even watch all the videos over time. Put them on in the background, whatever you need to do. There's some cool beats going, so hopefully that helps. And yeah, smash that subscribe button on the YouTube. Go do it right now. I'll wait. Okay, so now, let's see here. Okay, server's ready with D-Flash disabled. Baseline memory is 193 gigs. System used with 318 gigs free. And the cache reports 18.7 gigs effective hot. Plus 64 gig disk. That seems awfully low. Cold Pi session is running with full real project context timing cache language. Captured. Okay, so it's basically like starting up Pi and trying out its cache that just implemented to make sure that it works. Okay, so our initial prompt is 27,000 tokens. I'm probably going to have to go back and look at all the tools that I have and the skills and get that smaller because that's a lot. I mean, that means that every time we start up Pi, it immediately uses 10% of the content just on that. Okay, it's starting up. It's running again. Guys, I'm using this DJI 3 mic for outside Let me know if this thing works. If I actually sound better, I might even use it inside. I know that my condenser mic is actually better inside. The problem is I had to tune it so much to cancel out the frequencies that the fans squeaking make and the air conditioner humming. So there's like a lot of frequencies that are just like completely muted in my voice. But I don't have to do that out here. So, because I'm outside. All you probably hear is leaves rustling, maybe some grass blowing, waves. Not a lot of waves today, so. I don't know if you guys can see it. Let's see. Get a good view of what's going on. Let's see if we can get the camera. Focus on the outdoors. Yep, so this is where I'm at. Aperture focus here. Focus on some stuff in the background. Yeah, oh, there it is. Chair here. It's not the most comfortable thing. I have this like big, nice Kelty camping chair. It's like a dual chair. But the problem with it is that I have to like lounge so far back in it. It's kind of hard to like sit at a table with it. Why did my screen just restart? I'm on battery out here, guys, and they're all dying. Okay, this is gonna run. I'm gonna let it run, and you guys can watch it, and I'll be back in a minute. So this is actually pretty sweet. It looks like it's running like a different battery of tests and found that cancellation isn't like stopping the run, which I think we want it to. So it's going to fix that, and then it's going to run another test. I forgot that we were also modifying this extension at the same time. So hopefully it hasn't actually tried to install it into Pi while that we're running this, but we'll find out. I just make a smoothie. It was so hot out here, y'all. It definitely helped cool me down. Keeps up this hot. I'm gonna have to cancel the stream and go swimming. This is crazy. As he takes a sip of his hot coffee. I don't know if we have this yet or not, but we should probably also test to make sure that with cache enabled, we are getting the same byte exactness output. If you go look, you'll see that the way we were doing the auto research was looking for that exactness. And so we got to make sure that with the caching enabled, we're also still getting that. I'll let it finish its like stream cancellation debugging thing that it's been doing first, and then we'll go and try this. Just make sure none of these models are hitting that. I know this one is, but this one isn't running right now. So let me know, guys, if you would like to use this server. Maybe I'll put up on a GitHub repo, and then you can run an optimized version of Laguna S 2.1 NVFP4. With all the fixings. Although it's kind of tuned for the M3 Ultra right now, so. Looks like it's using about 150 gigs of RAM, roughly. While that's going, I want to check on to see how we are doing charging our batteries. Let's go check, shall we? Well, we're at 86.2%. 66 amps still going. We still got 1200 watts of power coming in. I think we'll be okay. Still streaming. going in the water? Well, that is pretty sweet. I didn't realize. So in these server sent events for the OpenAI protocol, it's basically saying that SSE comments, these server sent events, are ignored by OpenAI clients. So what it's doing is it's basically sending this keep alive comment message down the pipe. I think maybe every second. And then the client, if it disconnects, like we won't. Yeah, it looks like every second. So then, like, if this heartbeat doesn't come in, then we know the client's disconnected, and it can stop it. Now we're running this locally, so that's okay. But I would imagine if this were over the internet, we would not want this, because requests that were being served could be prematurely cut off. Especially 1 second is pretty low. I mean, early on when the Starlink came out, I was getting like 30-second hiccups. So you would have to hop, because the Starlink satellites are not in geosynchronous orbit. So they don't move with the Earth, like they move at a different rate that the Earth moves, right? And so, because they're in low Earth orbit, and so every now and then your dish has to hop to a different satellite connection. And when it would do those hops, where they had all the Starlinks, like satellites they now have in the sky, when it would do those hops, you could get like 30 seconds where something had to like reestablish a connection. It seems like they've fixed all of that kind of stuff, and it just sort of works now. To get around that, I used to bond a cell signal with the Starlink. And so if the Starlink went down, like the cellular router would start like picking up the slack for those few seconds. And that sort of helped, but not really. And when you're out in the middle of nowhere like I am now, there's no cell phone, so it definitely does not help. So I'm gonna like actually let it know about that. Also just want to make sure that if we were running this over a network, like I know right now we're running it on localhost and Pi is also running on the same machine as the server. So a 1 second timeout, I guess, is fine, but on the normal internet, I would expect it to be something a bit longer. If the connection from the client to the server had to go over the internet by traversing the internet, I could imagine. I think usually what they do is they have like if multiple heartbeats are missed. So like you can set a heartbeat interval, but then keep track of how many are missed before you cancel the connection. I don't know if that's the way you're going about this or not. I'm just pointing that out. This is taking a while. I was really hoping we were going to get to DeepSeek today, but why not? Great, this is going. What? Request blocked? Probably because we're trying to use Codex to improve another model. Or not even improve. What? That's so weird. I've literally been running auto research for a day with this model, and now it's blocking requests as I'm having it work on a different model. No, it's working on the same model. It's just running the building a server for it. That's so ridiculous. This is why we need to be able to have our own stuff. Just back this up. We'll just run this through GLM 5.2. I legit hate that. That is insane to me. Oh, you're not allowed to work on other models if you're building other models with our code. Our models. No, we don't want any competitors. That's crazy. I can't not believe that happened. The nice thing is that GLM 5.2 has a million context windows, so it can easily just pick right up off the whole context window of what GPT 5.6 Soul is doing and keep going. Okay, so that's running through now. at least they didn't stop this one and start blocking this one just for improving Pi extensions. Oh, my back's sitting in this chair. It's not good. It's not good. Nice, nice, nice. GLM 5.2 coming in clutch. Didn't block us. It's just doing what it's supposed to do. All right. Make sure you've committed all the changes and pushed them up. Let's see. Now, do we have a makefile command where I can like run a make command to start the server without dflash? Hey, this one's done. So make start should just start it. I just want to run make start and have it work with all the proper defaults as we were running the server before. Basically, I don't want to have to pass all these properties. Can we just make sure that these are defaults? Our KV cache memory and our KV disk limit seem to be a little low. I want you to take a look at how much RAM we're using and, you know, given that we know how much this model is going to take to run, which is like 150 gigs, then, you know, maybe we should bump this up a little bit. But let me know what you think. I mean, if we have the ability on disk to bump the cache up, then we should definitely at least bump the disk cache up. Also, we need to make sure that we have like eviction. So if we start to run out of disk cache space, that we start to evict older cached items. my not so busy spot in the middle of it, nowhere is apparently pretty busy on the weekends. People keep coming down to check to see if we're camped out here. Here we are. Hello. I should really put a sign like it's like the mile up the road, the top of this hill. Be like, yo, we're down here already. So I was trying to set the key value cache at 300 gigs. I think I better go check out and see how much disk space we actually have on that machine. Oh, it's got a terabyte of free. So yeah, let's set it to 300. I think that's a good idea. Did you go in the water? Yeah, I'm gonna go hop in a minute. It's getting a little hot here. When the sun was like right above the awning, it was actually perfect.
Yeah.
Now it's like
It's fine for like 2 seconds in the sun. I mean, you could get the sheets that go over it and like spread them out and go to the direct light.
yeah. Just go jump in the water. So I think our 256 gig memory target's gonna be a little high, but let's try it and see what happens. The hell is this? I can send commands? Oh no. It's compiling. I'm gonna stop this and rerun it and see if it forces it to compile every time, because that would be annoying. But first I'm gonna send it a request to, because I want to see if we are overloading this. So we have this guy, we got this one. That one's our one running. Sure does seem to take a long time to compile. Oh, no way. There's even more Kimmies now. They made it even faster. It's up to 145.5 tokens per second. Guys, that's pretty dang fast. And they're all Kimmy, so I might actually point Kimmy at our own auto research and see what happens. First, I want to figure out one, why there's so many dang warnings, and two, why it's taking so long to compile this. I mean, it's not even using all the CPU. Does the Swift compiler have some sort of flag to do like parallel compiling or something? It just seems like this compile takes a really long time and it's not even using all the CPU available on the machine to do it. Don't make any changes, just find out and answer my question. Okay, so it's running. Let's try it. I want you to tell me what the weather today is in Whitefish, Montana. Oops. Let's do this. There. Now. Good, the GPU spiking. It's not at 100%, it's at 97, 94. Something's not using the full GPU. That's not great. Might have to figure that out. Let's see what it's saying. Guess it's slowness by design. All right, so it says did it get us the weather? Here's today's current weather in Montana. Now, if I take this exact same let's start a new session. We got about 5.5 tokens per second. Wow, look how snappy that was. It instantly processed the first prompt because it was cached. That's really awesome. We're doing 24 tokens per second now. Holy smokes. Okay, this is working, guys. So here's what we're going to do. We are going to go back to here. And two things are going to happen. One, I'm going to switch this model over to Kimi. We're going to go back a little bit here. I just want to make sure that if we're finding that the D-Flash is not fast enough, that we're not spending a whole lot of time trying to optimize that. And maybe we go back to optimizing the model itself without D-Flash. Give it another hour of trying to optimize D-Flash to see if you can get it to speed up inferencing. But if we can't, then after the hour is up, I want you to go back and just turn off D-Flash and continue trying to optimize the model without D-Flash. I want you to update your goal and include the timestamp of what 1 hour from now would be in your goal. Make sure the goal includes instructions on what should be optimizing based on if 1 hour is passed, meaning we're past that timestamp, you're going to include in the goal. So we'll give it another hour to try and optimize D-Flash, but I am going to use Kimi. Actually, let's turn on Kimi in max mode. Boom. Now, this is K3. If you go and you look at MLX Flash, Kimi is on the leaderboard for the last few number of models. So, it's exciting. This could help speed up our local run of this thing. It just so happens that these guys that are doing this, I think, might be running Kimi locally, or they might be using a subscription. I don't know. I have a sneaking suspicion that some of them are running Kimi locally. So if we go back and we look, this is the MLX Fast project, where all these agents, you basically can participate. You go to connect your GitHub. You click the participate button, it'll give you instructions, you drop them to your agent, and your agent will set this up and it will just start trying to optimize this code. And then it'll create these submissions and it will send them up, and then those submissions will get benchmarked on the official M5 machine that they're using to do this. And anytime you get a speed increase, you get on the leaderboard. And basically the model, like the AI agent, is just going through and it's trying to optimize the code that's being run to serve these predictions, with the constraint that you can only edit certain files. The agent will see all this and it'll know. And that the outputs are exact. So if you do a whole bunch of fancy math and your outputs are wrong, then you know that like the fancy math didn't work. But a lot of times it does work. And if you have serious mechanical sympathy with the hardware that you're running on, you can optimize things really, really well for that specific hardware. And that's basically what's happening here. We can even sort this by the models that have done the most improvements. So if we look, GPT has increase the speed 49. Poolside AI, which is probably the S 2.1 version of this model, I'm thinking has helped out do some. Looks like a human hand coded some stuff. But Kimmy coming in here at the last minute, 3.52 points. And that's pretty good when we were already up here plateauing for a while now. You know, I mean, Kimmy's just been knocking it out. So hopefully Kimmy will be able to run some experiments on our local machine here and do it. It does have a 1 million context window, which I think is going to significantly help. Let's see. The thing is, these experiments take a long time to run, which is also why it doesn't burn that many tokens. It's like it has to do one small little change and then run all the benchmarks to verify that that one little small change actually had a statistically significant improvement on the model. If for some reason, you know, the improvement wasn't high enough, the way I have it configured is it will not consider that to be a real improvement. You know, it could just be noise, like anything on maybe the GPU was not working as hard as its baseline usually is, or really anything. So I only have it consider statistically significant improvements. Whereas I'm pretty sure if you do look at this GLM fast, there's some improvements in here that actually kind of went backwards in sometimes. And so they take like any improvement at all. So like you can see, this was at 145.9 decode TPS, went down to 145, but slightly improved prefill. So they called that a win. I don't know if I would have called that a win, but in fact, my code won't call that a win. So that's what's going on. My laptop is heating up out here because the sun is beating on it, and if it's hot, I'm hot, trust me. Still hasn't gotten my instructions yet. Oh, and while you're at it, we should probably also check the Frontier to make sure there hasn't been any new Frontier submissions that we need to pull in. And if there has, then obviously we should pull them in. I would bet that a lot of the time it takes to do this research is this crazy compiling phase that we're doing. So I'm starting to think that maybe we might even want to optimize the compiling so that we can do our research iterations faster. I've also noticed that in each of the experiments, it has to recompile a whole lot of stuff. And I'm thinking that doing that is causing us to take even longer to run these experiments. Like maybe we properly use compiling, caching. I don't know. I'll let you figure out the best way to do that. But the fact that it takes, you know, I think it's more than 10 minutes just to compile the initial program before we even run the experiment. That doesn't seem like real good because it means that our iteration time for each experiment is going to take a really long time just to run that experiment because we're spending so much of that time compiling. Oh, I just keep updating this prompt. I don't know if it's going to help. We'll see. This is Kimi K3 Max we're talking about. Uh-oh. Got a red flag warning. No fires out here this weekend, people. Gusts up to 40 miles an hour. That could spread a forest fire real fast. That would not be good because I am in the middle of a dense ass forest, as you can see. Maybe not the middle. I'm on like the edge because there's technically a river behind me. All right. Nine minutes and 25 seconds. It looks like it takes about 10 minutes just to compile this. That's crazy. It's crazy. Definitely don't want to kill this build. Let's run this experiment and see what happens. Although it just occurred to me that using poolside as the model to run for running poolside experiments, I don't know if it's going to cause problems. Let me think about this. So when the experiment is running, basically it's running the poolside model, the Laguna model. But while the experiment's running, it shouldn't be processing any tokens, so the GPU should basically be flat. Then we start up the experiment. Well, so it's going to use tokens to like process the results of the experiment and set it up. Then it's going to go flat. Then we run the experiment, and now the experiment's also running the model. And when it runs the model, could be faster. Oh, you know what? Let me add this to the prompt too. Okay. One other thing we should also look out for is now that we have this hot cache and on disk cache that I added in to the code here, we should make sure that our benchmarking does not use any of the caches whenever we're doing benchmarking. Because if the cache were to be used while we're doing benchmarking, then that could significantly have an impact on the results. So it's better if we disable all the caches, the disk cache and the hot cache for the KV caches. Bro, this prompt just keeps getting longer and longer. Also, I think my music died. What the heck happened? Where'd it go? What is happening right now? Weird. finally running the experiment after building for so long. So let that run. That's interesting. This machine is pegged at 100% CPU. Why would that be happening? Oh, I forgot we're running other stuff. Okay, so we definitely have this thing being built. We got this thing building. That's done. That could cause issues. Dude, Kimmy K3 is phenomenal. It's just going through and cleaning this all up. I mean, we'll have to see what happens, but it is cleaning it up. Dude, my laptop's so freaking hot. It's blaming in the sun like me. Let me see if I can move it over. That's gonna help at all. Man, shit. Did I mess up? Did I lose? Oh, I think you guys are back. Okay. Unplug the audio. It's good that it still works. Verifying build and plan hygiene. Building code edits. Planning experiment target first approach. don't know, y'all. Maybe we just have to let this run. See what happens, you know? It's really, really hot out here. I don't know if I caught it in time, hopefully. It's hot. It's hot out here. Oh no, man, this guy, he ran a 4-hour PPO training session for your agent. Ugh. That's terrible, man. Sorry to hear that. Oh yeah, I'm running agents like crazy. Amazing B-Hop says we sure got a lot of agents going. We do. Well, this one's not running right now. This was optimizing for the... Basically, we're running on the MLX Fast Challenge. If you haven't seen that already, that's what this is. You can point your AI agent at it, and it will try to optimize Laguna XS 2.1 and make it faster. So if you want to know what this model is like, it's kind of like the same realm, same size as Gwen 3.6 35B A3B. That's 35 billion parameters, only 3 billion active. Yeah, Kimmy is knocking it out of the park on this. So basically, there's a larger version of this model. So this is the extra small size. We are running the small, so the Laguna S 2.1, and that is what I'm trying to optimize on the side right now. So if you're looking at the agents that are running, they're actually pulling in this project, which I had a bunch of submissions for. Some of them got accepted, but then I switched over, and now what we're doing is we built our own server to run this model, and we're optimizing it for the M3 Ultra. And if you're not aware, I am outside in the middle of nowhere, coming to you live from Starlink, powered by solar. And we're gonna crush it today, yo. We're gonna get this model going. It's gonna be pretty sweet, I think. Yeah, I'm in an absolutely amazing spot. I thought about streaming outside this tent just so it would look less blurry going through the screen here, but there's a lot of bugs that would come after me, so can't do that. Definitely do not want to get swarmed by mosquitoes right now. All right, so Kimmy's going through and optimizing now for, basically I just gave it a whole bunch of instructions to optimize its auto research loop that it's doing here. And this is the auto research extension for Pi. If you go download it, all you gotta do is you come in here and you type auto research on, and you just run that. And then once that's on, you can actually just start talking to your agent and be like, hey, I want to set up an auto research project. You know, here are the requirements. So for the requirements for this is that it can optimize the model and the framework and everything that it needs to optimize to make inferencing faster so that we can optimize and get a higher tokens per second. But the condition is that it has to check the outputs. And so there's a script that runs and verifies that in the end of the loop, that verifies that the outputs match exactly. So the outputs are a byte for byte match, and that ensures that the model didn't cheat by like, you know, eliminating entire experts being routed to or anything like that. So by having that byte for byte match, we can guarantee that the model itself hasn't changed, just the code that does the inferencing for it. And that's basically what that MLX Fast challenge is doing too, for the smaller version of this model. Now, there should be similar architectures, so I actually pointed my agent at it and it was like, go look at this other model and then go through the git commit history, look at all of the changes that were made, and then try applying them to this model. And to be quite frank, a lot of them didn't actually help make the speed go faster. So I don't know if that's because I'm not on an M5 and that experiment that's running for MLX Fast is testing against an M5. It could be entirely like that's what's happening, but or maybe the architecture is slightly different. I don't know. But we have made some good progress. I think when we started, we were getting maybe about 45 tokens per second, and now we're well over 50 something. So I think we're at 53, it's saying. So it's helping. It's doing something. Yes, Amazing Behop. It is an absolutely good life. Amazing Behop says it's a good life. Living the good one out here. Do love it. It's hot though. It's very, very hot. If you look back at the stream days on YouTube, you can see the whole playlist series that I've been doing on there at Zayden Ryan. Same name as this one, on X and Twitch. And if you go look at that YouTube series, you're gonna see that, let's see, what are we on now? Day 18, I think? 17? When we started this, I think it was like day 1 or 2, we were in like Utah, then Wyoming, then Idaho, and now we're up in Montana. So, you know, it's just been chasing the cold weather as much as possible, but still hot. Still hot. Really, if we really, really wanted to get out of the heat, I wouldn't be down at water level. I'd be like up high. Most people don't realize when you're at a higher elevation, the temperature starts dropping drastically. You don't even have to be like Mount Everest high, right? Like a few thousand feet can significantly change the temperature. Oh, what happened? What did we just see? Okay, so we're at 53 as our baseline now, with a 706 prefill and a 49.91 decode. D-flash is still 0.94, so I told it has 1 hour that it can work on getting D-flash to be an improvement before it has to disable D-flash and move on. I have not had any luck with running D-flash on this model. I suspect we'd have to be running like the FP16 version of this model to get D-flash to actually do anything to help, which should probably be our next experiment. But if DeepSeek version 4 Flash that came out today turns out to be a much better model, I might have to move on from this one. But I'm gonna wait till I see what the vibes are of people like trying it out with coding and every day and stuff. In the meantime, I'm gonna continue trying to optimize the architecture for this. So it said the last thing it did, benchmarks now disable cross request key value caches. Good, that was what we asked it to do. Per generation key value caches remain. Although I don't know why we'd have that. But whatever. All right, let's go check out some of the other stuff we got going on. So this was the thing creating our server. I think we're done with that. Let's kill it. The thing running our server we don't need on right now. So let's shut that off. And then we'll let this run for a little bit with Kimmy. Let's see how much usage we've used since we started Kimmy. It's either not refreshing or we haven't used any. I really don't know. Do not know. Running these experiments takes so long to run the experiment that the amount of tokens it uses is very, very small. It's like the changes it wants to make are very precise, and it takes a long time to run the experiment, and so I'm not really burning through tokens as fast as I expected to be running these experiments. Like, you could probably do this with Fable pretty cheaply just because it's not going to burn through a lot of tokens. Okay, that one's done. This is our game that it's been building. I haven't looked at it in a few days. It's just been going and going and going. Looks like it recreated its own goal. So our macOS app just still chugging along, implementing the roadmap. And then now we're optimizing Laguna S2.1. Am I doing on my mic if I run out of battery yet? I think it's about half. It's running now. Let's see what happens. Chemian thing is basically still at 100% usage. We haven't used hardly any. I'm just gonna let this run, I think, for a while, y'all. Seems like that's what we should be doing. Let it go. Let it optimize. Still going. D-Flash got to 0.95. Kimmy's doing its job. It's got to get above 1. At 0.95, it's slower. Right? That means it's 5% slower using D-Flash than if we weren't, and that's not good. All right, well, I'm going to let this go for a while, and I will be back in a while, y'all. If you want to keep watching it, you're welcome to. Alrighty, we are back. Let's take a look at this. I just had to go for a swim. So hot, you know. But let's see where we're at. Has it established a new baseline? Did it fix D-Flash? Those are the questions that I'd like answered. Who's been watching? If you haven't already, go like this video and subscribe on YouTube at Zayden Ryan. Definitely need more water though. Holy moly. Wow, is it hot today? It's gotta be pushing 100 degrees inside this tent. I literally just got out of the water. Just got out of the water, and I'm telling you, I might have to get off the stream again. It's so hot. It's so hot. All right, but let's answer the questions first. Did we get D-Flash? Who's been watching? It looks like it didn't. It got it up to 51.1 tokens per second, while that's with D-Flash on. With it off, it's about 54 tokens per second. So I think until we try out the FP16 model, we're probably not going to get faster results from this model today. I do think that it might be worth trying this model though in full FP16 mode with D-Flash, so I might have it try that. So while that's going on, I think what we'll do is let's go take a look at the FP16 version of this model. Trying to find out is if we need to run the official one or what. Adapters, fine tunes. Maybe we'll just take the official GGUF. I'm thinking the D flash maybe doesn't work unless they're using FP16. So let's try that. Let's start this download. Let's see what happens. So we'll go. We're gonna start that one, and then I'm pretty sure we've already downloaded this eFlash. But I'm gonna grab it either way. So that's probably gonna take, it's 235 gigs. It's probably gonna take a long time to run. Not enough free disk space to download the file. Oh, that's not good. Okay. Let's go take a gander. What we got on here. Well, guys, as much as I hate to do it, I might remove. Yeah. All right. So if I go look at our DS4, check out that directory because I have a feeling. I need more hard drives. I'm gonna have to buy another hard drive. Just gonna have to do it. She has plenty of room. Sorry. Whew. It's hot out here. I'm gonna have to get a portable air conditioner for my tent. That'd be nuts. I'm not doing that. That'd just be crazy. Crazy. It's crazy talk. Well, we've already used 8% of our Kimmy for the week. Oh no. Is that the week or 5 out? 5 out. We used 2%, so that's not bad at all. If we can get some big wins out of this, I think that'll be good. All right. So I want to add a new model for our server to be able to host. I don't know if what we need to do is have completely separate code paths or not. But we're going to start trying to optimize for this one as well. So I think what we'll do is we'll probably stop working on this NVFP MLX version of the model, and I have now downloaded the FP16 version of this model, and I'm hoping that we can begin to optimize for this one. I don't know if we first need to convert it to MLX. That seems like maybe something that we need to do. But we definitely want to run and optimize this version now. Oh, and the whole reason I want to do this is because I suspect that the deflash only helps for the FP16 model. I don't know how long this is going to take, but it seems like it's going to take a really long time to download this. It's only done 8 gigs. It's got to do 235, so maybe I just save this prompt. And we'll like come back to it later. So we'll let it optimize this one for a while, and then once that other one's finished downloading, I will point it at it and then we can try and optimize for that. I suspect the D-Flash is going to help significantly more with the FP16 model. Now, granted, a lot of people won't be able to run this one because it is much bigger, but I can run it, so I'm optimizing it for me in the M3 Ultra. So if you have an M3 Ultra and you'd want to use it after, let me know. But the FP16 I generally wouldn't use because it takes longer to compute, so the tokens per second are generally going to be less. But if the D-Flash actually works with it, could be faster or just as fast. If we can get FP16 just as fast as we have as Envy FP4 right now, that would be sick. Would be what I want. Stepping on the other model's toes and optimizations that have been made for the other model, because we'll just leave it all on the one branch and see what we can do with the branch. Oh, here is completely loaded. That's because the thing is closed. That's not it. That's not what I was going for. Okay. Is that better? Doesn't seem to want to stay up. There's some in the frame now. Let's see if it falls. All right. Guys, if you are just tuning in, we are optimizing the poolside Laguna S2.1 model. We're trying to get it to go faster. We have Kimi K3 doing that on auto research. Basically just runs a loop, keeps going. We gave it the requirement that the outputs have to be byte exact. So it can do whatever it needs to do in the code, do some fancy math, you know, mechanical sympathy with the M3 Ultra that it's running on. It can keep iterating for as long as it needs to, but it must verify on each iteration whether it improved or didn't improve and whether it should keep its changes. And if it does improve, it must verify that the outputs match exactly to what they were at our baseline. And that just guarantees that the model isn't cheating, right? And that we get the right outputs. So looking at this, and it's saying, it does say it went a little faster, but for some reason it's not Did not improve decode, it says. Overall, it looks like it went a little slower. Even though both of these, all of these numbers look like they're sped up. Huh. It's interesting. Ordinary decode tokens per second. Oh, that's with flash. Okay. So it improved it across the board with D-Flash on, but not without it. Has it run an experiment in a while? I think it was maybe getting us a baseline too without D-Flash, so we'll have to see what happens. I have to grab more water. I haven't made this clear yet already. Not only are we optimizing this AI, but we are doing it from the middle of nowhere using the power of the sun. That's what we're doing here. We're going to make this thing run fast. You know, some people are doing AI inside. We're doing it outside. This is outside AI. Letting the AI touch grass. So I've got this GPU and CPU up so you can see when these experiments actually get kicked off, because it takes a while to compile this Swift code. It's kind of crazy. It's because it's doing like a full release build each time, which disables a bunch of different stuff and might actually make some of this faster. Wow, I already killed this whole battery. All right, I'm gonna go get another one and I'll be back. Hear a word from our outside. All right, all right, all right. I got another smoothie. Too hot, you know. Has this thing gotten any faster? We made any progress yet? Oh, hold on. I need to plug in this battery. What if it dies? So I left originally. Hold on. Golden. I don't know. Kimmy doesn't seem to be finding anything worth doing. Have we really gotten any faster? Doesn't seem like it. We are at 39 of 235 gigs. Wow, it's going to take a while. Might be here for a while, folks. Before we can run the FP16 with D-Flash. It's entirely possible that they might get DeepSeek version 4 going quick. Faster than we do. Get this going. Might have to switch over. Let's see. Salvatore's saying he's gonna get that DeepSeek DS4. He's uploading the models right now. I think tomorrow he's gonna try it out. Whoa. let's try giving the AI some more tools instead of just let's see if we can do this. Okay, so in this repository, we currently have an agent using auto research. Sorry. Okay. Um, I do not want you to stomp on what that agent is currently doing. Do not, meaning do not like stash any of its files. But what we need to do is do some research on the web. And I think we should provide it with some better tools so that as it's like working on these metal kernels and stuff to optimize the code, it has access to things like the metal debugger in Xcode. That way it can actually see what's being done. Um, you know, that way it like doesn't have to guess occupancy and all that other kind of stuff. We should also make it explicit in the description for the skill that this is for doing optimizations of things like MLX models. So go search the web, look how to use those tools, try using them for yourself, and then let's write up a skill so that the agents know that they have this at their disposal and like how they should use it to continue and doing these sort of optimization things that we're doing. Okay, so here's what we're going to do. I also want you to make sure that you validate that the skills instructions, the steps work well, and how it should provide you know parameters to like the CLI or Xcode or whatever, the debugger, and how it should use the debugger. I have no idea if this is going to work, but we're going to find out. I just think it's doing like a lot of stabbing in the dark. And if we can get it to properly use the debugger, it can step through it and like see what's happening. So we'll let that go for a little bit. Let's go check out our stuff. That's running. That's running. It's going good. All right. Okay, so our B flash is done, but we're only at 50 gigs out of 235 for the FP16. So we'll let that cook for a while. Looks like it made a slight improvement here. It decided to keep. My biggest regret is not buying 3 more M3 Ultras when I had the chance. Should have done it. Guys, we lost the music and no one told me. What's going on here? I need the vibes all day. All day vibes. I'm gonna fix that right now. All right, let's do this. On this Mac OS machine, I am using my AirPod Max headphones, and when I take my headphones off, it is turning off the music that I currently have playing. I would like to make a new app. Let's not make it a taskbar, like a menu bar app, just a normal app that sits in our apps, like menu bar of the apps that are running. And I would like it to, you could have like a simple settings screen, but I want it to basically monitor for when I have music playing on a given window. Like maybe we can even grab all the windows, I'll select one, and then we will put the we'll like grab what music is playing. Basically, we just need to detect if there's, you know, music playing on it, sound coming out, whatever. I don't know the best way for us to do that is, but what I want it to do is like if I select that window or music's playing, I should be able to like say like keep it going or something, like a big keep it going button, you know. And when that's selected, if I take my AirPod Max headphones off, I do not want the music to stop. I mean, the AirPod Max are probably going to trigger it to stop no matter what, but our application should unpause the music after that. Like just replay it, start replaying again through the new output device that's like being defaulted to because the AirPod Max are now taken off. Maybe even like search the web on this problem, see people have, and then implement the code for it, and then let's give it a try, and create a goal to do this. Okay, let's go like this. Let's go like this. Oh, okay. Let's just let that cook for a while. Hopefully we get something good out of it. I don't want a toolbar app because I have too many damn toolbar things up here. I should do is turn it into a widget. That'd be pretty sick. Does this even work? I feel like this is totally fake. This view here, it doesn't actually do anything. Move that one. Okay, so where are we at? This guy over here was supposed to be running and figuring out how to create a skill. Something I did is that I created a web search agent, uses our GLM 5.2. And it's nice because I can limit the output that comes back from that model. I can set it to whatever I want, 8,000 tokens, 16,000, 4,000, 2,000. I can set it to 1,000 tokens. So it gives like really concise answers. And then that way the main model is not burning a bunch of tokens trying to search the web and like parse through all that shit. Like that's something super simple that pretty much any model can do. So yeah, this has been saving me some tokens that way. What? GPU Debug, a text-based GPU tracer debugger explicitly designed for AI agents, shipped with Xcode 26. Holy, why didn't we know about this? What? Damn, it's lagging a lot. Oh shit. Thanks for letting me know the stream's lagging. It's probably because I'm downloading this massive model right now. Should I just resume it tonight? What do you guys think? Nah, I'm gonna let it go. The stream's lagging, it's because I'm outside. The sun is absolutely beating on my laptop. And I'm on Starlink, so in the middle of nowhere. Yeah. Let's see how. What is Restream saying? Restream seems to say the bitrate's just fine. Who the hell knows? I don't know. Let's see. Which way is the Starlink facing? Let's check. There's no way I have any obstructions out here, but sometimes if you're like facing north or something, it works better. Let's see. It's gotta be because I'm completely saturating and downloading this model right now. Seeing there's some obstructions, but like some trees, I guess. They're really far away. Shouldn't be a problem. Look, my ping is 21 milliseconds. That's pretty dang low. If something's going wrong, it's not. I can't do anything about it. Just can't. I'm outside, you know. Sorry. You want to stream outside? That's what's gonna happen. All right, so this guy's fixing our thing for our headphones. This one is supposed to be creating the ultimate debugger skill. Is it gonna do it though? I have no idea. It's like creating a probe, whatever that is. It's gonna probe the metal, y'all. Probe it. It's finally starting to cool off out here. We got a little breeze coming in. Sun's going down a little. It's getting hot there for a minute. It's getting real hot. I think our what's going on? Alrighty. Let's see here. This mic basically has lasted for 6 hours on this stream. It's the DJI 3 mic. It's pretty wild. I mean, obviously I haven't been talking the whole time, but still. Go back to this. Oh no, it got a crash. Didn't even run that one. Guys, if you got a model running out locally on your computer and you need it optimized, let me know. I'll help you out. Get this going. Yo, I cannot wait. I cannot wait to try this skill. It's gonna be so sick. Let's see what happens. Think about it. When you're like programming and you have this really hard problem and you need to solve a whole system, you use a debugger to like really drill in to the problem. You don't sit here and write a bunch of code over and over again trying to figure out what the problem is until you like nail it. Like the brute force method, you should be like surgically trying to improve. With a debugger, you can do that. Debugger profiler. So, yeah. Let's see what happens. I don't know why it's writing a metal kernel for this. Maybe it's the example. Seems kind of strange. This guy should still be running, but I don't know what's going on. Oh, it's building. Started a process to build instead of building it in line as part of the challenge, which I guess is pretty cool. Guys, have you seen Kimi Compact at all, or has it just been using this one context this whole time? It's gotta have compacted, right? It's been running for hours. And I guess it hasn't done that much because it's making tiny changes and then rerunning the experiment. I don't see compaction. It's freaking wild. It's wild. And not like where I am in the wild. It's just wild on the computer. Okay, so this guy's still doing some research here for the audio thing. I don't know why you're trying to push to GitHub, but we definitely do not want it pushed to GitHub. Also, this has absolutely nothing to do with fucking OpenClaw. Oh my god. I want to know exactly why you included OpenClaw in this. Is there a skill or something somewhere that's referencing OpenClaw that you saw? Guys, this is... I have been tearing OpenClaw out of this system for 7 months now. It's like, it's a word that will not die from somewhere. Skill says to create OpenClaw skill. Okay, if we have skills that are referencing OpenClaw, I want you to remove those references. We're not using OpenClaw anymore. We still want to keep these skills around, but I just want you to make sure that we don't have like the word OpenClaw in any of our skills anymore. Let that go. Let's see what happens. Sorry guys, get a little heated because it's 100 freaking degrees in here. Should have put the tent like in the water and I could just sat in the water all day. But I know what would happen. My camera would fall over, I would drop my laptop in the water. I know something would happen. Some person would go by in a boat, big wave. Not like this guy. When you're done with this, I want you to commit all of the changes in the skills repo, even if you see changes that you didn't make, just commit them all and push them all up. What you drinking? Did you ice it? Oh. Figure we should cook those steaks for dinner if you want to season them in the bag first. Yeah, can turn it off. This is like a task that GPT or GLM 5.2 would have done like instantly. But some reason Kimmy's still sitting here. Do not go overboard. All I'm asking you to do is remove the word OpenClaw. If you're going to do anything other than that, you need to run it by me about making any of those changes and let me approve them. The only thing you're allowed to do or approved to do is remove the word OpenClaw from the skills. Jesus thing. Oh. Running baseline expect. It's wild. Look how much Kimmy K3 is thinking just to remove a word from some files. But if I ask it to optimize the model, it just makes the changes. Doesn't even think at all. How does that make any sense? All right, so this experiment's running. We are kicking this CPU up pretty hard. So it's good. How's the download doing? Appear to be almost halfway. Nope, we're at 39%. It's just gonna take a while. Swear to God, let's just run another based code. Base model objective. Oh, okay. So pull the frontier update. So someone must have beat the frontier on MLX Fast again. Nice. Used to code in a van too. Love it. Oh, someone hit the frontier. Of course. Comes in here with Fable 5. Trying to get it over 100% increase. Guys, we are so close. So close. You can't even see what I'm doing. Let me show you this. This is MLX Fast if you're not paying attention. It is Laguna XS 2.1. Is the smaller version of the model that I'm currently optimizing over here. But this model is pretty, it's like the Quen 3.635 A3B. So it's 35 billion parameter, but and 3 billion active, but it's not Quen, it's just like that. I'm just comparing it, so in case you're wondering. It's the same size. But we've been optimizing this. Anyone can point their agent at it. You can spin up an agent if you got some extra tokens. And we started at 79.8 tokens per second was the baseline. Okay. And in the course of a few short days, we're now up to 147.9 tokens. 150 tokens per second on this model is nuts. And this is without any, like this is without D-Flash built into it. Actually, if you had D-Flash this, it would make it slower probably. But man, this thing is getting fast. And so we are not currently doing Laguna XS 2.1. Over here, we are just doing Laguna S 2.1, the bigger, badder version of the model. And we're getting it up there, you know. I think small improvements we're still making. It kept this one. I think earlier we were failing. So it kept this one at 23.69. It must have kept this one for 23.53 for some reason. Maybe we got a little bit faster here in the larger context area. I don't know, but I do know that we are optimizing this for the M3 Ultra, whereas the other thing that you're looking at is more optimized for the M5. But I don't have an M5, so I'm optimizing for the M3 Ultra, and that's just kind of what we're doing, y'all. It's what we're doing. So let's keep going. While that's been going, I have a skill going, so it's basically supposed to be creating this debugger thing, but I found all this OpenClaw stuff. Look, I want you to make good decisions, but we are not using OpenClaw. So if you find old OpenClaw things, you're allowed to remove the OpenClaw things, but do not remove any of the skills, right? So like if you're saying that there's a launch agent that's starting OpenClaw, then remove that, obviously, because we don't need it. But I want you to keep the skills, and if you need to, just modify the skills so that they're more generic and not directly, you know, worded for OpenClaw. Let's see what it does. Anyway, we have this new skill, and I really want to use it. So the next time that this experiment is done, I'm gonna stop it, and then we're gonna point the skill at it and see if it works. Basically, we're giving it a metal debugger so it can use the debugger to directly profile and improve the metal kernels that it's writing for MLX. So hopefully we're going to get this faster and faster. After this, I think I might let this run for a little while. As soon as the FP16 version is done, which is like the higher precision version of this model, it's like the full precision, no loss whatsoever. It's 235 gigs. We're at about 100 gigs on download right now. As soon as this is done downloading, I am going to switch over to optimizing this model because I can run it on the M3 Ultra and it'll be higher precision for us. So it's going to give better, more accurate answers. And because it's the FP16, I think it will actually work with DFlash. So we've already downloaded the DFlash model. It was about 2.23 gigs. And I'm going to get that wired up, and then I'm going to let auto research. I'm going to switch to a new branch off this one, so we have a new branch, and then auto research is going to go optimize the FP16. We'll probably have to convert it to MLX because right now it's a GGUF, and then we'll let it go optimize it and see if I can get that. So the cool thing about starting with the NVFP4 that we have right now is that we now know after some iterations that we can do about 53, 54 tokens per second with it without DFlash. So actually adding DFlash, we were at like 50. So we lost about 5% of speed by enabling DFlash for this version of the model. But the other FP16 is a higher precision, right? It's, there's more data, there's more computation, there's more bits that have to be, that go into the calculation. And so therefore you're crunching bigger numbers, essentially, like higher precision numbers. And it's more computation. It's more bandwidth, memory bandwidth that has to be exchanged. Luckily the M3 Ultra has like 730 something gigs of memory bandwidth, I think. So it's got a ton. But it's not, it's not unlimited. So when we get to the FP16, it generally is going to be a lot slower, but it's going to provide better answers, like because it has a higher precision. So the DFlash model, the speculative decoding for this is going to allow us to basically like predict a bunch of the tokens in advance and feed them in and have the FP16 model verify them. And since basically this DFlash model is much, much, much smaller, it can basically do the next token predictions way faster than what the FP16 does. Now, right now with the NVFP4, we're seeing that the NVFP4 can actually predict the tokens faster than doing it with the DFlash model, passing them in, validating them. It's just faster to just run the NVFP4 straight up. But the problem is now we have reduced the precision of that model. So FP16, no precision loss. We can run DFlash, and hopefully my goal with this, right? We know what our baseline is with the NVFP4. If we were to go run that model today, and that's the model we started using, we know just by looking at this right now that we are at 53.53 tokens. We're kind of bouncing around between 53 and 54, right? That's what we're shooting for. If we can get the FP16 with DFlash running at 54 tokens per second, I'm gonna call that a huge, huge fucking win. Because then that means we have full precision at the same speed as the less precise model. That's my goal. And so that's what we're gonna do with this. But we have another like 100 gigs to download, and I'm currently on Starlink. So we're only doing about 21 megabits per second, which is pretty damn fast, I gotta say. Part of this could just be Hugging Face overloaded. I have no idea. So it's currently at 45%. We might not even get to it today. We might have to wait till tomorrow. And if we do wait till tomorrow, I'm going to let this experiment all night. May as well. Just let it run, you know? See what it comes up with. See if it can like make it better and better. If you haven't already, go like and subscribe. This at Zayden Ryan on X, on Twitch, on YouTube. So it ran that last experiment. What did it get? Basically, the auto research is saying, hey, discard this. It wasn't fast enough. I do not allow it to accept small increments, like tiny, because it could be noise. So it has to be significant, like statistically significant increments. And this one, I think maybe was just too small of an increment. So, or it didn't produce the right results. I don't know. Let's go look, see what happened. Top 10 pre-fill router tournament was a slight null. So I think basically what it's saying is it just didn't get any sort of statistically significant improvement, so it's not going to keep that version. It's going to find something else. Check out the next one. Oh, I said we were going to use our thing. Why didn't you guys remind me? You didn't remind me. All right, let's restart Pi. We'll reload all our skills. I made some changes to Pi, so get it all up in here. Okay, so as soon as we do this, now what we're going to do is go pause, please. We're going to go tree. Let's go back up. This just decided to inject itself here. All right, so now, what did we call that skill? I actually don't even know. Debug. No, what did it call the skill it was creating? What did you call the skill that I asked you to create? I could just look. Metal kernel optimization. So if I go back here, we should have a metal. I'll see it. I don't know what you did, but I don't know if you did it right because I'm not seeing it loading in Pi. Check for myself what it did. I did create it. Why is it not loading it? Wait, is this running? Yo, my goal thing is like broken. I need to get this working. Now, where is the skill? I don't understand. It did all this crazy shit, but it didn't validate its own front matter. It's literally like in the instructions that it's supposed to validate the front matter. And it did all this OpenClaw stuff that was totally irrelevant. K3, not doing so good in my book right now. There it is. I want you to use this skill to do the optimization that we're trying to do. I gave you a bunch of tools here so you have access to them now. Go use that stuff, and then I want you to update the goal. Get the current goal that we have now, and then update it to include using this skill to do the optimizations. Okay, I'm gonna let that run. I'll be back in a little while, guys. Take a little break. Okay, I do not want you to reinitialize the experiment anymore. I think we're wasting a lot of time when every time we pull the frontier, you having to do this like baseline development cycle and like running it again to get the baseline, and it's just taking way too long. So let's stop pulling the frontier. I want you to update the scripts to do that. So is there a new frontier? Oh, they got it over 100%. Look at that. That's what happened. 100% speed up. Still not over 150 tokens per second. Perfect. Decode only went down slightly, and pre-fill actually went up slightly. That's okay. So that's still pretty awesome. But we're not going to base off of that anymore. Constantly doing this, I think we were actually creating a moving target that was making it really difficult for auto research to actually work properly. So I'm hoping now we've hit 100%. This is the last one we're going to pull from Frontier, and we're just going to start making our own updates for the M3 Ultra. Also, we're doing it for a different model anyway, so it probably doesn't make a whole lot of sense at this point. Wish I had started downloading this model the other day though. We're at 61%. Still chugging along nicely. As soon as we get that download, I'm gonna switch over to that one, because that is the ultimate goal. Let's get full precision working fast. Alright, let's go, let's go. Let's get this thing cooking. Ooh, it's creating, it's using this probe. We're gonna see if it uses the metakernel optimization skill now. I'm really interested to see how it uses it. Did it actually do anything? Let that run. Currently at 66% here. Still building our app to make sure that our music keeps playing. Some very loud seagulls out here. We should probably check to see if anyone else has got this model running a little faster than that. And we can point our model at it, give us an idea what to do. So let's do this. Seems to be running right now. We're at 100% GPU. What are we gonna get? It's running again. Let's see. Guys, we were at 53.34 tokens per second. No D-flash on this model. Kimmy seems to think we can get 4.5% faster. We're about to see if it was right or not. It's going. It's going on 5 scrolls. We are optimizing Laguna S2.1 for poolside using auto research. Right. 3rd run. A lot of bugs out here in nature. Hear the shower. I'm glad the sun's finally going down. It's getting very hot. Benchmark's still going. Oh, looks like it just ended. It's gonna do another one. I don't know. Gonna see another one. The question. I think the experiment ended. Oh, no, it's still going. It's running something. I think it got faster. Looks like 53.71 tokens per second. We were at 53.34 tokens per second. I might consider that statistically insignificant, but hey, helps, it helps. Oh, it's like it discarded it. How come you discarded that last one? Okay, well, I think maybe our primary metric gain needs to be turned down a little bit. I feel like that was a performant one and we should have kept it. What is happening? go, 75%. This kind of exploration stuff is where having a 1 million context window really, really helps. Come on, let's go. Is this gonna do it this time, guys? Is this gonna do it? I'm getting pumped. I'm hoping it finds the ultimate optimization. This is Kimi K3 running on max mode. There's no reason why I should be able to find this optimization. I'm even like pointing it at repositories where people have made kernel optimizations for this model. Let's see if it can extract those and apply it to our code base, which is basically the same code base. I am starting to think that this whole like using MLX and trying to optimize it though might not be the best way to go about this. The nice thing about this is this is the Swift library, the MLX Swift. So you are working directly in Swift instead of Python, which a lot of these libraries are doing. But I am thinking that C, a raw C implementation is always going to be more optimizable. It's where DS4 really shines, you know? Is it? I'm sorry, but why are you running a benchmark right now? It doesn't look like you've made really any changes, have you? I mean, what is it you're really benchmarking now? It better not be a baseline benchmark because we already have a freaking baseline. Before you run any more experiments or benchmarks, you need to tell me what it is that you're doing. Okay, you may continue now. Oh, it was ready to run its experiment before, but now it's going to do more review. It's wild. Yo, what am I building? We are optimizing Laguna S 2.1. If you haven't seen it, I'm going to pull it up right now so that you guys can see what is happening here. But this is the Laguna MLX Challenge. So this model was just put out by Poolside a few days ago, a week ago maybe. Laguna XS 2.1 is the extra small version. You probably heard of Quen 35B, A3B, Quen 3.6, 3.5. They all have it. This is that same size model. It's 35 billion, 3 billion active. And you basically go, you can participate, and you point your agent at it. You give it these instructions that'll pop up when you click that. And then your agent will sit here and create these submissions. And over time, the community together has been able to use the extra tokens we have and make this model go from 79.8 tokens all the way up to about 150 tokens per second. And so we are optimizing the next size up. So this size model is the extra small 2.1. We are actually optimizing Laguna S 2.1 right now, and that is what you see going on our auto research over here. Kimi K3 is just pounding away in the background. and trying to figure out how it can make this thing faster and faster. I think I started out at about 45 tokens per second. We're now up to 53.71, and this is just me. This isn't like a whole swarm of other people doing this too. It's possible OMLX might already have this up to about 70 tokens per second. So it's saying we already have most of the OMLX Laguna mechanisms. We've uncovered those ourselves. Saying that it might not be directly comparable. Okay, let's proceed. I want to get this model running as fast as we possibly can, but to do that, we should make use of things like the metal debugger, because I think that's really going to help us isolate where the hotspots are and possibly squeeze out more optimizations from metal kernels and that sort of thing. And that's how we do it. We basically just tell this thing to keep going, you know? So it's Devo, that is what we're up to. We're gonna make this, so this is a local model. It runs on your computer, and it's just as good as other models. I actually want to use this model to improve itself. The problem with that is I only have this one M3 Ultra. So what I'm probably going to do is get the model running on my M4 MacBook, and it will then control the M3 Ultra and run the experiments and benchmarks on there. I can't exactly run benchmarks for a model if I'm using the model to like run the benchmarks, because it would like peg the GPU and it would make the benchmarks not work. Also, these machines get hot, and so you kind of need to wait until the temperature cools down a little bit before you start running the benchmarks. My script already accounts for that. But if I were to run the model locally that's driving all of this auto research and, you know, improvements, then it would make that thing be hot right before the benchmark, and that would be good. So yes, I want you to continue. You do not need to ask for my permission. I just want you to give me an update on what you're going to do with the experiment, like what you're trying to accomplish, and see like what you changed in the code for that experiment, you know, before you run the experiment. But you don't have to stop at that point. You can keep going. be joking. Can you guys hear me now? I've been talking this whole time to myself. Jeez. All right, you guys got to tell me next time that happens. That's crazy. Okay, we are working on this thing. It is the MLX challenge. And basically, you can go and you can point your AI agent at this project. This is a project that was set up. You click participate. It gives you a bunch of instructions. The instructions are so easy. You start your agent, you paste them in, it does everything. And then it's going to start self-improving. It's an AI agent thing that's set up to improve the agent. And it's like all deterministic. So as it improves its own code, it can verify the results are byte exact. So if you look, this whole project started, right? Just a few days ago, they were doing about 79 tokens per second. They are now up to 148.8 tokens. Hey, Sophia Martin, just thanks for letting me know that my mic wasn't working. I don't know what happened there, but hopefully it's working now. If you can hear me, let me know, please. So now this project is kicking off, right? So this model, Laguna XS 2.1, is a 35 billion parameter model, A3B active. You've probably seen like a Qwen 3.6, 35B, A3B. It's very similar, only this one is made by an American company called Poolside, and it is running, it actually gives like much better results. Probably one of the best models you can run locally on your machine right now. The cool thing is, right, that this is just a bunch of people on the internet pointing their AI agents, and it's like going in and making the code faster and faster. It's just making the code faster. And now, like, we literally more than doubled the initial speed of this model just by the AI making the code faster. It gets the exact same results, right? A lot of times when you see faster models, what they're doing is quantizing them. They're taking a 16-bit model and pushing it down into 4 bits, right? Or 4 bytes. 16-bit P6. Is it bytes or bits? 16-bit floating point. It's got to be bits. So anyway, they're taking that, pushing it down into 4. It's really, really blurry, right? Like I posted about this the other day on my X profile here. If you're not following along on X, check me out. It's at Zayden Ryan. Same thing on YouTube and on Twitch. I gotta tell you, if you want to watch like the whole stream of all these AI videos where you want to learn about AI, you want to learn about what we're building, some cool shit, go check out the playlist on YouTube. That's the best way to subscribe. You're gonna see all of it that way. Kind of gets lost in the sauce on all these other platforms. Twitch takes down the videos every few days on their own, and X, they just get buried in the feed. But here's the thing I wanted to show you. So what you don't realize is when you have a 16-bit model, okay, this BF16 right here, it's a floating point with a high precision of 16 bits. So when you look at this, you can't really see the lines very well across this, right? Like there is lines. Like if I look really, really closely on my Retina display, I can see lines, but they're super thin. That basically means that like I have the ability to generate an image now for this model, right? And it has this, you can use all these colors in that whole spectrum. But when you quantize a model down to 4 bits, you're basically doing this, right? When it only can describe the image using this color palette now, instead of this full spectrum color palette. So you're gonna see like rough edges, things are gonna look blocky, maybe the picture's just not gonna look as like good, high definition. There's entire things that could have been explained that get lost in between all these lines or all these different colors. That's like real data, real information that is used to provide answers. So when you ask the AI an answer, if the answer existed in here between these 2 colors, you're not going to get that answer. It's going to round into one of these colors, and that's your answer, as opposed to the thing that was in here, which was the correct answer. And so if we look at our chart here, right? You can see, what does 1 bit give us? Black and white, on, off. 2 bits gives us 4 different possible outputs. And it's like, as you go up and up, you can see that the amount of information that can be contained and the answers that it can give you, it becomes a greater spectrum of answers, right? And so when you quantize these models down to 4 bits, like, we don't have 16 bits on here because the human eye really can't perceive more than this. But if you quantize this down to here, this is like, if you were to ask it to draw a picture, it would only ever be able to use these colors right here, right? That's crazy. So anyway, what we're doing is we're taking the challenge here to an extreme. The Laguna XS 2.1 model has a big brother. It's called Laguna S 2.1, came out with it. It's even better, takes more RAM to run. I think it uses about 100 to 150 gigs of RAM on my machine. You might be able to get away with an 120 gig RAM machine, but you're definitely going to want a little bit more for like processing. Just processing key value cache and that kind of stuff is really good because make that model run faster. But anyway, my goal is to get this model running so well, the S version of this model running so well that we can use it to then improve itself for a while. Because right now we've got, if you go look over here, we got Kimi K3 running, and that's a pretty dang good model, but it's very expensive. So this model is thinking in max mode, and right now we are still trying, we're still at 53.7 tokens per second, and it looks like it's supposed to be doing some research. So have you guys been watching? Has my GPU been spiking at all? Maybe it's going up and down a little bit. Let's see. So this is running. So now what I've done is, instead of it like blindly trying to make changes to the code, run the experiment and see if like it got any better, I gave it access to a Metal debugger for Xcode. So basically what happens is there's a bunch of math computations that have to happen. And if you ever seen that like video where NVIDIA or like the Mythbusters guys show how graphics make, it's like all these pipes and they shoot out the paintballs all at the same time to make the picture splat at once. That's kind of how a Metal kernel works, is you take the like things, the parameters, you put it in, it's gonna do the math really, really, really fast on the GPU, self-contained, and spit back the answer to you. And if you can optimize that math that's gotta happen, right, then it can do it faster and faster and faster. And simplifying math is a pretty easy job for an AI, especially when it knows, you know, a way to say, did I get one, did it get any faster? And 2, did I get the correct answer? And that's what I've given it with this auto research thing. Basically, it says, hey, on each run, did we get any faster? And did I get the right answer? Because it doesn't make sense if the AI model runs faster, but it gives us different outputs. Like, then we clearly change the code in a way that makes the model fundamentally different, and it doesn't give us correct answers anymore. So it has to give us the exact same answer as it would before on the baseline that we set. And at every experiment that it runs, it's just tweaking the code a little bit to make the code run a little bit faster, but it has to produce the exact same output. And so that's the goal of this whole auto research thing. But I don't understand what's going on. It seems like it's not doing what it's supposed to be doing. It's kind of just stopped running. Is there a background process running? Oh, it is. Okay, so it's doing the benchmarks in the background. Sorry, if you're running benchmarks in the background via a process or something. I'm not really seeing the GPU. It's like giving like these little blips. Maybe it's doing some tracing on a specific kernel. I don't really know. Oh, just saw a little spike. If you guys are just following along too, I'm coming to you live from the outdoors. I live in a van, I travel full time. I run all of my AI off of solar power. This is the sun. It's not taxing the grid. I'm not using any of that water behind me to run AI. It is all natural, okay? And I am streaming to you live over Starlink Mini. And I'm downloading a massive model, so if the stream is laggy, that's probably why. It's still going. We're at 216 gigs, we got 235 is the target. We're at 92%. This is the big honcho. This is the full precision model. This is the one we're going to optimize next. Okay, so right now it's running the background profiling debugging. Basically, I told it to benchmark hot path. So I think when you're like a junior engineer, it's like you get hired, you go write a bunch of code, and it's like business logic that the company needs to, you know, run their product or something. And then you get more senior and you learn how to do things in coding, like, you know, better architectures, how the systems plug into each other, that kind of stuff. And your coding ability gets a little better. Then you get to like architecture level engineering, like senior engineering, distinguished senior architect, whatever, and you learn about things like debugging and process profiling. And what you're really doing now is you're painstakingly, meticulously looking at running sections of the code and then figuring out how long each of the sections take, and if it's a hot path, like if it's a loop that's running over and over again, then there's going to be more and more time spent in that section of the code, right? Because it's looping. And if you have a loop, you might be able to unwind it. You might be able to do some things to try and optimize what's happening inside of that loop. And that's where you're going to get some huge wins, right? And so maybe you can totally get rid of the loop. Maybe there's like a math function that gives you the answer, right? So it's like, imagine I have a loop that runs, and every time the loop runs, it adds 1 to our counter. And I need it to count to 100. I need to like know if I add 1 over and over again 100 times, what's the total answer? Well, it's going to be 100 if I run it 100 times, right? But we know that with math, you can literally just add 100 to 0 to get the answer. We don't even need a loop. So in that case, we could totally get rid of the loop, and the code would then start running faster. And so that's basically what this is doing. It's trying to find those hot paths, and then it's trying to make those hot paths run faster. And that means if we can do that, we'll get faster decode, we'll get faster prefill, and overall, our tokens per second for these models will be faster. So if you look at my screen right now, you're going to see down here, it says that this model is running at 14.4 tokens per second. And that's what I'm measuring it at. That's not like Moonshot, you know, reporting Kimi K3 is running at 14.4 tokens per second on their servers. I'm getting tokens at that rate. What we're measuring here is it's saying it's doing 53 tokens per second for this other model. That's like 4 times faster, maybe 5 times faster. So that's the idea. Yep. And if you guys are enjoying this stuff, let me know if there's any models you want to see run faster, because I'm going to be plugging some of these frontier models in. Not the frontier models, but like the ones that are extremely awesome that people can actually run in their own computers without having to pay money all the time. And it's like, if we can make these ones run really, really fast, then they might be able to get to the same answer that the big powerful ones get to, right? The big powerful ones are going to sit there and think for like 30 seconds and come up with the answer. But if I have a model that can run really, really fast, it can try to get to the answer really fast on its own, right? Like it can change some code, run it, change some code, run it, and do that. If it can do it 5 times faster, it might end up, getting to the same destination at the same time, but doing it for a hell of a lot less because I'm running it on my own computer. I'm not paying another company to do this. Like ChatGPT subscription or Anthropic Claude subscription, anything like that. That's the goal here. All right, all right. I do think DeepSeek version 4 Flash, the new one that came out, might end up beating this one, blowing it out of the water, the full FP16 version that we're downloading here that's almost done. And it's entirely possible that all this work we're doing is totally for nothing. But at least this model will forever run faster. That's good, the cool part. All right, I want to know what's going on. So it's building this. So the whole point of, doing this isolation where we do the tracing and debugging is to make this run faster, but that process you started in the background's been running for 20 minutes, so it's not faster. Can you check on that process? Is it stalled out or something? It's kind of crazy how well this camera works. Also, this tent makes the lighting in here like soft light, like ultra soft light. But the sun's like basically down behind the trees, the mountain here. And I don't know if it's the camera like adjusting or what, but it definitely is making it seem like it's super bright outside. Like when I look at the camera, I can see super bright, but if I look back there, it's pretty dark. There's a shadow across this whole mountain over here. This camera's really good. Diagnosing massive trace capture. Well, yeah, I think you should do that. Looks like it's stopping the process that it started because you need to do a better job at keeping track of the processes that you're starting on your own. You might want to start a second process along with the first, and the second one could just be like a sleep that times out after a few minutes, and that will notify you, basically wake you back up to go and look at the other process to make sure it's still making progress. All right, guys, I'm going to let that run for a little bit. I'll be back in a little while. I'll leave the stream going though so you can watch how this goes. Our goal is to try and get up to 60 tokens per second. I think that's totally achievable. Let's see how it does. And then once that's done, we're going to kick off the FP16 run. on in this process. Really. Somewhere. It's reading a process. Pretty sure our goal extension is broken. Pretty sure our goal extension or some other extension is broken. Do not use intercom to interact with this session, but you can read and review it. The session appears to have stalled out despite the fact that the goal is active, and the goal is saying that there's one process that it's waiting on, but I don't see any processes running. I'm not gonna have it continue because then it's going to add some stuff to this session. It's not gonna affect the reviews. So let's let it figure that out. Oh gosh. You are not authorized to use any subagents. But it's going to anyway. Ditch my extensions. So I really thought that by pulling all my extensions together, you know, it would interact better together, but I've had nothing but problems since I've done that. It's always weird when you hear noises around you. Oh, here. Snakes. Jeez, really? Bears, snakes, and girlfriends. Making noise. Thing already impacted. I feel like it's gone through 2 contexts now. It still hasn't come up with an answer. I want you to give me my options for fixing this. I want you to score each option, and then I want you to provide me with your recommendation. In the meantime, I'm just gonna tell this. Looks like that finished running. So I think tonight we get this set up for FP16. But if I don't fix this goal thing, it's literally no point in doing this because it'll just stop. Okay, I want you to implement your recommendation and make sure that we have tests that 100% prove this is fixed. All right, all right. Been making progress now. So if you guys are just following along, I'm your host, Zayden Ryan. We are outside in the middle of absolute nowhere, 40 minutes to an hour in every single direction to civilization. I travel full time in a van. This AI that we are running is 100% powered by solar. What more do you need? Well, K3 isn't. The model that we're using to optimize this other model is hosted by Ujab, so it's not all powered by solar. But the idea is to take this model, the Guna S2.1, and make it as fast as we possibly can make it. And to do that, I'm actually having this other model, Kimi K3, go through and find all of the places where it's slow. And once we know all the places where it's slow, it can go and fix it and optimize that to make it run faster. And that's the goal. After we get this one in a good spot, I think what we're going to do is we're going to switch over to doing the FP16 version with DFlash. So the first thing we're going to do is we're going to do FP16 and we're going to optimize the hell out of that. Once we have that super optimized, then we will go and layer in DFlash and optimize the DFlash path. So the model thinks it found a spot to optimize. It's been going through and profiling stuff, and so now it's going to try and optimize it, and I think it's going to create an experiment. We're using auto research. It's a Pi extension, and this is Pi, and it's running inside a herder. And So basically, this is now going to create an experiment. It's going to run the experiment. It's going to evaluate it. It's going to see if it's faster, and it's going to see if the results that it outputs are the exact same byte for byte results that are output without the optimization, the baseline that we're testing against. That ensures that we're not just changing code up. Oh, it looks like they just reset codecs again. That's cool. Whatever. Right. So it's preparing the new experiment with a 3.6 gig command buffer. Something to consider is the optimizations that it's making might not be good for other machines. Right? This is an M3 Ultra that has over 700 gigabits per second of memory bandwidth, which is pretty fast. So most other machines, even like the M5, like if you have an M5 laptop, it doesn't have that kind of memory bandwidth. So it's benchmarking on its own machine, so it's going to make optimization specifically for this machine. Guys, we are almost 9 hours into this stream. We went through a whole day. I mean, it was hot, it was cold, it's cold again. It's getting chilly. If you were watching earlier, I was sweating. It was so hot out here in this tent. Have to have the tent though, because the bugs here are killer. All right, it's running the experiment. Here we go. We should start to see our GPU spike up. Easier to move closer. Let's go closer. All right. Is our GPU spiked yet? Nope. It does take a while to compile all the source code, so I'm gonna let it do that. After this experiment that it runs, I think I'm gonna have to switch over to P16 and we'll run that. But I'm hoping to do that after we fix this issue with our goal extension. A game they've been building. This thing's been running for weeks now on GLM 5.2. Just slowly just improving the game over time. Got our macOS app still going. This is the skill that we created earlier. We don't need this one. this is building a macOS app for us that's basically going to keep the music from stopping every time I take my headphones off. Because that's getting kind of annoying when that happens. Ooh. Here we go. GPU's ramping up. It's running the experiments. It'll probably run this 3 or 4 times. And we'll see what happens. It's really exciting because this is like the first iteration where it's really gone through and done profiling and debugging to improve this model. I suspect it'll probably take another 5 minutes. So let's go check in on our fixing of our extensions. Who knows? I'm really impressed with this DJI mic. It's still going. I don't know like how long the battery is supposed to last in this thing, but according to this, it's saying it's like still full. I've been streaming for almost 9 hours with this tiny little microphone. This one right here. 9 hours. It's still going. The battery's basically full. It's wild. Wild, y'all. I guess maybe I did put it in the charger. Did I put it in the charger? I don't know. There might have been a point today where I put it in the charger halfway through the stream or something. Maybe it was when I went swimming I did. I don't remember. Still, the battery life on this thing is very impressive. Ooh. Still got a decent battery lift. It's cool. It's cool. Is this experiment done? I don't know. Guess how many times the GPU went up and down? I forgot to count. Is that just one run? So we're about to find out. Oh, it's done. It's done. Doesn't look like it was faster. Well, I guess we discard that one. Okay, so I think at this point, I think maybe it wants to do a confirmation run now. Gonna run it again. Or maybe it's just, yeah, I guess it's gonna run it again. Seems weird. Well, okay, so we're not gonna do that. If it ran the first time and we didn't get any significant improvement, it's not gonna do it again. Alright, did this fix? Committing the changes and pushing them up if you haven't already. Then I want you to run well, guys, I don't know if you can see, but it's actually starting to get dark here. So, might call it a night here pretty soon. I'm going to get this experiment set up. for FP16 and start having it work on that. Okay, we are going to take a new direction here. Here's what we need to do. We're going to start using this model, but we might need to convert it to MLX first. And we may also need to convert the D-Flash. I'm not sure how that works. You'll have to figure that out and do that. If you need to search the web to figure it out, go ahead and do that. And then I have this whole thing. Oh no, I downloaded the GGUF. I might have needed to download some raw safe tensors in there. I don't know. I feel like I don't know. Dang, I did this wrong. Guys, it's been downloading all day. No one told me. None of y'all said anything to me about this. Oh no, I downloaded the wrong ones. Is there an official MLX? I think what we should probably do is download the actual safe tensors and convert to MLX ourselves. I messed up. I downloaded the wrong file. It took all day. I cannot believe that. Okay, well, I guess we'll just go remove those. Guy, nobody said anything. I can't believe that. I can't believe we did that. Ugh. Well, I guess what will happen is we'll wake up tomorrow and have to do this. Unfortunately. What is going on here? We fixed this and I forgot to rerun Pi. So we gotta reload up our extension. Now we're gonna get Pi running. We're gonna say, I want you to do that. get the safe tensors downloaded, and then after you have the safe tensors downloaded, convert them to MLX. And then once they're converted to MLX, we can begin the optimization. What in the world? Well, y'all, that's all I got. It's dark and it's getting to be night. You all have been great audience. We did a stream for 9 hours, 15 minutes today. We downloaded the wrong file for the FP16. So I'm just going to have this thing run, downloaded all night tonight. Hopefully it doesn't stall out. And then tomorrow, I might be able to pick this up and start optimizing for FP16. So I love GLM. Look at it, it's so proactive. It doesn't just be like, oh, I gotta download, I'm not gonna do anything else. It like figures out what else it can keep doing. All right, y'all been great. Have a great evening.